All right, let's talk about a problem every developer dreams of having. You build an amazing application, it takes off, and then it grinds to a halt. Why? Well, it's usually the database. Today, we're going to look at the two classic solutions for how to scale it.
So, picture this. You've launched. People love your app. The user count is going up and to the right. But then you start hearing it. Hey, is the site down? Or why is this page taking forever to load? You've hit that classic growth wall, and it's a frustrating place to be. So, what's really going on under the hood? 9 times out of 10, maybe even more, the problem isn't your fancy front-end code or your powerful servers. Nope. The real bottleneck, the part of your system that's screaming for help, is that single database trying to do everything for everyone all at once. It's just getting completely overwhelmed. Now this pressure, this traffic, it isn't just one big monolith. It actually breaks down into two very, very different kinds of problems. And you know what? Figuring out which one you're facing is absolutely the key to picking the right tool for the job. So on one hand, you've got high read volume. This is your classic media site or e-commerce store, where thousands of people are all trying to look at the same stuff at the same time. On the other hand, you've got high write volume. Think social media apps or logging systems, where a fire hose of new data is constantly pouring in. Each one of these needs a totally different approach.
Okay, so let's start with the first one. You've got way too many people just trying to read data. If your app is read-heavy, the solution is a really beautiful and elegant concept called replication. So what is replication? Well, at its heart, it's a super simple idea. Instead of trying to make your one database server magically faster, you just make more of them. You create exact copies. I mean, if one server can handle 1,000 users, it just makes sense that 3 servers can handle 3,000, right? It's all about duplication. You know, a really great way to picture this is to think of a busy restaurant. You have one master chef. They are the only one creating new recipes. Those are your rights. Then they hand that recipe off to a whole team of apprentice chefs who do nothing but churn out copies of that dish for all the customers. The apprentices? Those are your read databases. It's this perfect master-apprentice setup. So let's trace how the data actually flows. Say a user writes a new comment. That's a write operation, so it goes to one place and one place only, the master database, which we also call the primary. As soon as that data is saved, the master turns around and sends that update to all of its copies, the slave nodes, or replicas. Now, when tons of other people want to read that comment, their requests get spread out across all those less busy replicas. Simple and effective.
And the wins you get from this are massive. First, you get incredible read scalability. Getting more traffic? Cool, just spin up a few more replica nodes. Problem solved. But the second benefit is just as important. High availability. What happens if your main database server crashes? Well, you're not totally out of luck. You can just promote one of the replicas to become the new master. It's like having a hot backup on standby 24/7. But, and this is a really big bet that every senior engineer needs to understand, there is a trade-off. It's called eventual consistency. See, there's a tiny, tiny delay, we're talking milliseconds, between when data gets written to the master and when it shows up on all the replicas. We call this replication lock. Now for a blog, who cares? But if you're building a stock trading app, those milliseconds can mean everything. And that brings you to a major architectural decision. By default, most systems use asynchronous replication. The master gets the write, tells your app, got it, and then updates the replicas in the background. It's super fast. The danger? If the master crashes right after saying got it, that data might be gone for good. The alternative is synchronous replication. Here, the master waits for at least one replica to confirm it has the data before it says got it. You're guaranteed not to lose data, but it makes every single write a little bit slower. It's that classic trade-off between speed and safety. Okay, so replication is amazing for handling tons of readers. But what if that's not your problem? What if you're getting crushed by a tsunami of incoming data, or your database is just getting so huge it's unmanageable? For that problem, replication doesn't help at all. You need a completely different and way more powerful tool, sharding. So here's the key difference. Replication copies data. Sharding splits data. You're not making duplicates. You're taking one gigantic database and chopping it up into smaller, faster, totally independent databases. We call these little pieces shards, and each one holds its own unique slice of the total data. Think of it this way. Instead of having one enormous encyclopedia with everything from A to Z, you break it up into separate volumes.
Volume 1 has A through C, Volume 2 has D through F, and so on. Now, if you need to look up zebra, you don't have to search through everything. You just grab the TZ volume. That's exactly what sharding does. So how does your app know which volume or shard to go to? It uses something called a sharding key. This is usually some piece of data you already have, like a user's ID. Your application code looks at the user ID in a request, does a quick calculation, and knows instantly, this user's data lives on shard number 3. Okay, don't let the code here scare you. The concept is really simple. You can use a basic math formula. You take the sharding key, like the user ID, run it through a quick hashing function, and use the remainder, that's the %, to figure out which shard it belongs to. This little piece of logic becomes the traffic cop for all your data. For apps with tons of writes, the benefits here are an absolute game changer. Your write traffic is now spread out across multiple machines, so you can handle way more of it. Plus, since each individual shard is so much smaller than the original database, things like searches and index lookups are just lightning fast. But, and this is probably the single biggest warning about sharding, you have to choose your sharding key wisely. This is where senior engineers really earn their pay. If you pick a bad key, you end up with what's called a hotspot, which is what this chart is showing. One shard gets hammered with all the traffic, while the others are just sitting around bored. You've gone through all this work just to recreate the same bottleneck you were trying to solve. So we've got replication for scaling reads and sharding for scaling writes. You might be thinking, okay, so which one do I choose? Well, what if I told you that the biggest applications in the world, the Googles, the Metas, they don't choose, they use both. And here it is, the architecture for truly massive scale. First, you take your giant data set and you shard it into manageable chunks. That solves your write scalability problem. Then, you take each one of those individual shards and give it its own replication setup, its own master, and its own set of replicas. This is the best of all worlds. You get write scaling from sharding, read scaling from replication, and high availability on every single piece of your data. Wow. Okay, we have covered a ton of ground. So let's just take a breath, zoom out, and put these two concepts side by side one last time to make sure it's all crystal clear. Let's just run through this. Replication's main goal? Scale reads and keep your app online. Sharding's goal? Scale writes and handle enormous amounts of data. How do they work? Replication makes copies, sharding splits things up. The data itself, with replication, everyone has a full copy. With sharding, each server has its own unique piece of the puzzle. And maybe the most important point for us developers, replication is pretty straightforward to set up, but sharding is very complex to get right. Look, if you remember only one single thing from our chat today, please let it be this. Replication is all about copying your data to handle more readers. Sharding is all about splitting your data to handle more writers. They are two different tools for two very different, very specific jobs. So now you have the patterns, you know the strategies. The next time you're looking at a slow application, ask yourself, where's the pain? Are we drowning in reads, or are we getting crushed by writes? Because now you know exactly what to do about it. So, which bottleneck are you going to go solve first?